Hello class, this is a video tutorial on Geometry Part 5. In this video, we'll be looking at vertically opposite angles. A point where two straight lines intersect can be seen as the corner or the vertex of two shapes. Here's two quick examples of what I mean. So line AB, this has a point of intersection with line CD at the point H. But if you can just imagine, if we just join these two, you can see that point H is just the corner or the vertex of two triangles. Likewise with PQ and UV, PQ, UV, they intersect at point X. And once again, you can imagine there being two triangles like this. And point X is just the corner or the vertex of those two triangles. You could also imagine it going this way if you really wanted to. By understanding the properties of angles on a straight line, another property in geometry arises. So let's follow along here, okay? CHB plus DHB, this is a straight line, so those two angles must add up to 180 degrees. We know this because that is the property of supplementary angles. Now, to make this a little easier moving forward, let's start labeling these. CHB, let's call it angle X. So this is X. And DHB, let's call that angle Y. Whoops, Y. Oops. Okay, so let's leave that there for now. All right, so we know that those two are X plus Y, and we know that because it's a straight line, X plus Y must equal 180 degrees. Now let's keep going forward. DHB, and that once again is that angle Y plus AHB, that must also equal 180 degrees. So for this, let's call that point, or angle Z. And for the same reason, that is also a supplementary angle. So there we have it. But take a look. They are both equal to 180. So let me summarize this here. X plus Y equals 180, but Y plus Z is also equal to 180. Well, because of this, we can let them equal, so if it makes it easier, they are both equal to 180, so it must be the case that they are equal to each other, which is what this statement says here. It states exactly that. CHB plus DHB, that's X plus Y, so that's X plus Y equals DHB, once again, is Y plus Z. But because of algebra, we can subtract Y from both sides, which summarizes that X must equal Z. So in actual fact, even though I've used two different letters, we actually don't need to. Z is equal to X, or X is equal to Z, in which case I'm going to let that equal Z. So just using the supplementary angle proof, so this and these two angles, we can see that these two are actually equal to one another. Now, since this property can always be found when exactly two lines intersect, so rather than always repeating this set of reasons, we actually just give it its own named property. in that it is called vertically opposite angles. But it's not that it's vertical up and down, it's that it's opposite at a vertex. So, in summary, if we see two straight lines that intersect exactly at one point, these angles are equal, and likewise, these two angles here must also be equal because they are vertically opposite angles. All right, so let's just quickly demonstrate of like what I mean here. Well, what the properties show. Okay, so let's actually do these 4 problems. You can pause at any time that you'd like. So here we go. So for this one, we've just seen that because they're 2 straight lines, they are vertically opposite angles. So we can just simply state that x must equal 52 degrees, but giving a geometric reason, they are vertically opposite angles. Now, as we've done before, there's a short way of writing this long statement. Okay, so you can pause and give this one a go yourself. Hope you can see that x must equal 48 degrees. And here's the short way of writing vertically opposite angles. So it's going to become vert opposite angles. Now, we're not done with this particular question because it's easy to recognize the vertically opposite angles there, but now we have to try and figure out what y is. Now, I hope you can see that we are actually required to use prior geometric reasons. If you can see that this is actually a triangle, so it must be the case that the angle sum of this is equal to 180 degrees. So in this case, we write down 48 plus 62 plus y must add up to 180 degrees. That is the angle sum of triangles. And from this, we can solve what y is. Adding everything together, this gives us 110 plus y equals 180. Therefore, y must equal 70. So those are the 2 values we're looking for. Okay, you can pause and give the next few a go yourself. So here we go. For this, I hope you can see that these 2 are indeed vertically opposite angles, but we don't even know what A is yet. But if you can see, in this triangle, it must add up to 180 degrees. So we can state that A plus 20 plus 30 is 180 degrees. And once again, that's the angle sum of triangles. In solving for A, we get A plus 50 equals 180. And the missing value there, A must equal 130. And from this, we can see that B must also equal 130 because that is a vertically opposite angles. All right, one final question here. All right, so there's let's figure out what this might be. You can pause and give this a go yourself. This one's a lot trickier. Okay, so I hope you can see that these 2 lines, right, they intersect at these 2 points. Now, this is a little tricky because take a look. These 2 will add up to 105 because these 2 are vertically opposite angles. So these 2 going this way. So we can write that, okay, now watch very carefully, 105 must equal 78 plus y. That is vertically opposite angles. I'll go a little bit slower now here. So these two pairs are vertically opposite. It's just that this angle, like how about this? If I were to chop that away, can you see that these two are indeed 105? But because R chops this, it's still 105. So we can figure out what y is by subtracting 78 from both sides. Subtracting this, we get 97 plus 97. So I subtracted 8 to get 97. 97 take away 70 is 27 degrees. So y is 27 degrees. And for x, well, for this is actually a lot easier. If you just imagine this being a straight line, we chop it at this point. So this, we can just say x plus 105 equals 180 degrees. That is because it is supplementary angles. Well, from this, we can see that x must equal 75 degrees. Well, that concludes the examples for vertically opposite angles. I hope you can see that with vertically opposite angles, it's actually very simple, but it's that we have to integrate it in with other geometric properties and proofs. Hope to see you in the next video, and best of luck.